Hello guys, welcome to another video. This one is paper 1-1 of November 2020 for the IGCSE Add Math paper 1. Now with that being said, let's move on to questions number 1. So the diagram shows a graph of y equal to modulus of p of x, where p of x is a cubic function. So now whenever you see cubic function, you have to know you will have something in terms of x power 3. That's the first thing we can derive from that sentence. Now, we have to find the two possible expressions for p of x. So very easy. First thing first, we have to look at these points. So these points of intersection on the x-axis. So this is what? This is the value of x equal to minus 2, x equal to minus 1, x equal to 4. Now, for example, let's say I mentioned that we have a solution of x equal to a, for example. So what is a factor of that? Then we have to send this over here. It will be x minus a will be a factor. So same logic applies here as well. Given that we have three solutions at these values, we have to write down the factor of that. So basically, p of x will be equal to, send this over here, will be x plus 2, that will be x plus 1, and that will be x minus 4. So now we also have to check something, is that we have to use a passing point, which is this point, to verify the answer. This is the point of when x equal to 0, y has to be 24. So let's check if that is true or not in my question. So let's see. So when x is 0 here, my value of y, which is p of 0, is equal to minus 8. But wait, minus 8 is not the same as 24. So how can you change that to 24? You have to multiply by minus 3. Now if you multiply this by minus 3, you also have to multiply this by minus 3. So right now we can conclude that p of x is equal to minus 3, x plus 2, x plus 1, and x minus 4. Now that is one of the solution for p of x. Now the other expression is also very easy to find. The idea is that if p of x can be the expression, minus p of x can also be the expression. Why? Because as you can see here, y is inside the p of x is inside the modulus, which means that if you were to put, for example, minus p of x here, it is the same thing as p of x, because modulus change all the negative values to the positive values. So your answer will be, you can write down this and this, or you can just write this down as well, y equal to plus minus 3, and that will be x plus 2, x plus 1, and finally x minus 4 as your answer for the two expressions for p of x. So this is p of x, right? Not y. P of x. Okay, that is question number 1. Now let's move on to question number 2. So here we have to write down the amplitude of 1 plus 4 cos x over 3. So one by one. So before we write down the answer, we have to understand something. So let's say our equation was y equal to a cos b x plus c. Now the amplitude will be always this value right here, which is the value in front of your trigonometry expression. So same thing here. We verify this. In front of this, we have the value of 4. So 4 will be your amplitude for this one. Now moving on to part B. For we have to write down the period of this. Now to find the period t is equal to 360 divided by this value of b. So that's how you find the period. Now t will be equal to 360 divided by, what is the value of b in this one? If you observe, it is before the x. If you observe here, so cos, what is cos x over 3? It is simply cos 1 over 3 x. So this will be your value of b. So b will be 1 over 3. And you will get 1080 as your answer. So the period will be 1080 degrees, or you can write your answer in radians as well. It is up to you. Now for part C, we have to sketch the graph of this between these domains. Now, as you can see, it is only a sketch, so it doesn't need to be exact. We just have to somewhat show the shape of our curve. So just use your calculator to find the corresponding values for each of those points. So here we have 1 plus cos. Here we have x is minus 180. So 1 plus 4 cos minus 180 over 3. That will be 3. So first point will be 3. Okay. Now here we have minus 120, so we can just replace this here. That will be 4.06. That should be somewhere over here. Next one, 60. 1 plus 4 cos of minus 60 over 3. That will be 4.76. So 4.76 should be somewhere over here, I would say. And then cos of 0. So 1 plus 4 cos of 0. That should be 5. So 5 is right here. And then we have, so basically if you replace those values as well, you will get the same values as this. So this will be somewhere over here. This will be somewhere right here. But of course, you can always check using your calculator. You should be receiving or getting the same values as shown on this graph. Now we just have to join the points by a smooth curve, so try your best. That will be something like this. But of course, you have to be using a pencil for your graphs, not a pen. And once you connect all the points, always label the graph at the end. That will be y equal to 1 plus 4 cos x over 3. And this is your answer for question number 2. Now let's move on to question number 3. So here we have to write down this fraction in the form of this, where a and b and c are constant. So one by one, let's simplify. Now what is p square root? It is p power half. Next one, this we can break this down. That will be q power 1/3. R will be 2 over 3. Divide by, simplify, that will be q minus 3, p minus 1, and then r power 3. Now, we have to use the laws of indices in this question. For example, if you have a power, let's say a power c, multiplied by a power d. Because they have the same base, we can combine them into a c plus d. Now, same thing applies if you have a power c divided by a power d. Because they have the same base, we can combine them. That will be a c divide become minus d. So using these principles, we can solve this or simplify this step by step. So here we have p half. Here we have divide become minus. Here we have minus 1 become minus 1. Then we have q 1 over 3. We have divide become minus. Here we have minus 3. Here we have r. We have 2 over 3. We have divide become minus. And here we have 3. Now let's simplify one by one. So what is half minus minus 1? That should be p 1.5, right? And q, what is 1 over 3 plus 3? That should be this, which is 10 over 3. And this will be what? 2 over 3 minus 3. That should be minus 7 over 3. That will be part 1 of the question 3. Now moving on to part B. So here we have to solve the equation. Solving means we have to find the value of x. So step by step, the first thing we can do is we can realize that here we have 6, but we can break this down into pieces. For example, x 2 over 3 can be written as 1 over 3 power 2 minus 5. That will be x 1 over 3 power 1 and plus 1 equal to 0. So right now it may be confusing, as you can see. So what can we do now is we can use substitution. So let u equal to x 1 over 3. So you will have 6u square minus 5u plus 1 equal to 0. Okay, so now we have to factorize. So 6u squared will be 3u times 2u. 1 is 1 times 1. To get minus 5 has to be minus 3 minus 1. So u will be 1 over 3 and u will be 1 over 2. But now, of course, we're not trying to find the value of u. We are trying to find the value of x. Replace u by this initial value. That will be 1 over 3 is equal to 1 over 3. X 1 over 3 is equal to 1 over 2. Now, to eliminate this value, as you can see here, this power, we have to apply power of 3 on both sides. So we can eliminate this power, right? This is an idea on how to do this. Now, this will cancel out. So here you will have x is equal to 1 over 27. X is equal to 1 over 8. So here you have two values of x for your answer. That is your question, part B of 3. Now again, if you guys don't know how to factorize, you can always use the formula to solve that, because sometimes here, as you can see, it is very easy to make a mistake. For example, we can say, so two brackets, right? Here we have 6u. You can tell me, okay, 6u squared can also be what? 6u times u, right? And 1 is times 1 times 1, sorry. To get minus 5, we can have minus 6 and plus 1, right? But here, it is not right. Why is that? Because if you observe, when you take my plus, multiply by minus, you get minus. But here we have plus, so this is not good. If you verify here, minus times minus have to give you plus, so this is good. So this is the right factorization of this expression. But however, if you guys don't know how to factorize, no big deal. You can always just use the formula to find the answers. That will be question number 3. So let's move on to question number 4. It is given that y equal to tan 3x over sine x. Part A, find the exact value of dy by dx when x equal to pi by 3. Now, if you like to work with radians, you can do that. However, I'll prefer to work with degrees. So I know this is 180 over 3. That will be 60 degrees. Okay, so now one by one, let's try to find dy by dx. Now, as you can see, this one is a fraction, right? So tan 3x over sine x. So whenever it is a fraction, we have to use the quotient rule. So let's do that. So dy by dx will be what? So first thing first, write down the denominator as it is, multiply by d by dx of the numerator, and then minus the numerator as it is, multiply by d by dx of the denominator. And of course, everything divided by the base square, which is sine square x. Now simplify one by one. So here you have sine x is sine x, right? D by dx of this will be sec square 3x. And of course, multiply by 3 because of the 3x. And here minus tan 3x is tan 3x. That will be cos x. Divided by sine square x. Okay, so simplify that should be 3 sine x sec square 3x minus tan 3x cos x, and divide by sine square x. So that is your dy by dx for the first step. Now we have to find this value when the value of x is pi by 3, which is 60 degrees. So let's make a few notes here to see when we need to find. So let's actually replace this value in my equation first. Let's see what we need to find. So 3 sine of 60 multiplied by sec square 3x. So what is 3x? 3 times 60, that will be 180. Now what is sec square? It is 1 over cos square 180, right? If that makes sense. Now minus tan of 180, and cos of 60 with everything divided by sine square of 60 degrees. Now we have to know a few exact values to solve this question, because as you can see here, it is asking you for exact values. So first thing first, we know that sine 60 has to be what? Has to be root 3 divided by 2. Now next one, what is the value of cos 180? So I don't know this one, let me check. Cos of 180, that should be minus 1. Okay, and next we have tan of 180. So tan of 180, that should be 0. Okay, good. And finally we have cos of 60. That should be half. Replace all the values in my main equation. Let's see, what do we have? So we have 3. Sine of 60 is root 3 over 2 multiplied by 1 over, this is 1 minus 1 square will be 1. Then minus tan 180 will be 0, and everything divided by sine 60 square will be, so this square will be 3 over 4. Simplify. So that will give you 3 root 3 over 2 divide, which is divide by 3 over 4. As you guys know, whenever you have divide, you can change the sign to multiply. We just have to flip the other side upside down. That will be this over 2, change that to multiply, then flip this upside down. That will be 1, 2, 1, and 1. That will be 2 root 3 will be your exact value of dy by dx when x equal to pi by 3. That is your part 1 of the question number 4. Now for part B, we have to find the approximate change in y, as x increases from this to this value where h is small. So pretty easy. Approximate change in y is defined by the what value? By the dy by dx at the initial value of x, which is pi by 3, then multiplying by the value of h. So this we know already. It is 2 root 3. This is just h, so this will be your answer for part B. Now for part C, given that x is increasing at a rate, so whenever you see rate, it means we have something with respect to time at 3 seconds per second. So which means that dx by dt is equal to 3 units per second. That is the rate of increase of x. Now we have to find the corresponding rate of change in y. So we have to find dy by dt when the value of x is this. So pretty easy. First, let's form an equation. dy by dt can be what? So on top we have dy, as you can see here, and on the base we have dt. So that's the first step. Now, by what are they connected? If you observe, we have dx by dt, so we can just put dx here and dx here. Now for this value we know already, that should be 3. How about this one? So we need to find dy by dx at the value of x equal to pi by 3, as you can see here, when x equal to pi by 3. Now this we know already. If you check, this is from part A. This should be 2 root 3. Okay, so just replace back in your main equation. That should be 2 root 3 multiplied by 3. That should be 6 root 3 units per second for your answer for dy by dt. And that is your question number 4. Okay, so let's move on to question number 5. So here we have to find how many different 4-digit numbers can be formed using these numbers 1, 3, 4, 6, 7, 9, and each of those numbers can be used only once. So pretty easy. First thing first, let me write down these numbers. So 1, 3, 4, 6, 7, 9. And we have 1, 2, 3, 4. Now, for the first one, I can choose any of them. I will have 1, 2, 3, 4, 5, 6 options. Let me choose 1. Then I will have 5 options. Let me choose 3. I will have 4 options. Let me choose 4. I will have 3 options. Let me choose 6. Your answer will be 6 times 5 times 4 times 3. That will be 360 as your answer. Not degrees, sorry. That is one way of finding this. Now, if you want to use a formula as well, pretty easy. We have 6 numbers. We have to permutate 4 of them because we are choosing 4 numbers, right? So 6 permutate 4, that should be 360 for your answer as well. Now for part 2, how many of these 4-digit numbers are even and bigger than 6,000? Now, as you can see, we have 2 conditions to satisfy. So in that case, we have to look at case by case. So we have the numbers 1, 3, 4, 6, 7, 9. Now, these questions, I think we have done this many times in the past. So I expect you guys to know how to do this already. So if you don't, then you guys have to do this many times to understand how to do this. But it is pretty easy. Let's move forward with the answer. Now, for a number to be more than 6,000, so again, we only have to choose 4-digit numbers. So we can first, we know we have to have 1, 2, 3, 4, right? Now, for a number to be more than 6,000, we can begin the number with, if you think, it can begin with 6, 7, or 9 for it to be more than 6,000. Now, for a number to be even, we have to end with an even number. So the last number has to be even. As you can see, we have this is even and this is even. So these two are even. So now we have to look at case by case because we want to see how exactly we can combine those two in one solution. So let's do that. Case number 1, we can choose to begin with 6. Okay, so we have 4 space 1, 2, 3, 4. Now we assume we are beginning with 6, so we have to put 6 here. Now because we have only one 6, that will be only one option, if that makes sense. Let me write this down here. We have 1, 3, 4, 6, 7, 9. Now because we only have one 6, we have only one option of placing 6 in the first number. Now we need this to be even, so we can only end with 4. So we have only one option to end their number. Okay, so now we have 4 numbers remaining. So in between, we can choose anything we want to. For this one, we have 4 options. Let's say we choose 1. Then we have 3 options. Let's say we choose 3. So in the end, that will be 1 times 4 times 3 times 1. That should be 12 ways of beginning with 6 for a number which is more than 6,000. That is my first option. Now case number 2. What if we begin with the next one? Begin with 7, right? Again, same steps. We have 1, 2, 3, 4. The numbers are given to you as 1, 3, 4, 6, 7, 9. Now again, we have only one 7. So we have only one choice of using that 7. Now for the numbers to be even, we can end with 3 or 6. So we have 2 choices now. Let's say we choose 3. Now we have 4 numbers remaining. I will have 4 options. Let's say I choose 1. Then I have 3 options. Let's say I choose 4 for this one. So my answer will be 1 times 4 times 3 times 2. That should be 24. Now finally, for the third options, if you begin with 9, now you will have to use the same logic as in 7. So your answer will be same as 24. Well, I just don't want to show you the same thing again. I'm sure you guys can do this part. Okay. So to find the answer, you have to add everything. That will be 12 plus 24 plus 24. That should be 60 as your answer. That will be your question, part A of 5. Now let's move on to part B of the question. A committee of 5 people is to be formed from 6 doctors. So we have 6 doctors. We have 4 dentists and 3 nurses. But if you observe, together we must have what? 6 plus 4 plus 3. We have 13 people to choose from. Now part 1, what if there's no restriction? Pretty easy. From the 13 people, we need to choose 5. So 13 combination 5 will be what? That will be 1, 2, 8, 7. Now for part 2, the committee contains at least 1 doctor. So more or equal to 1. 1 doctor. So there's two ways of doing this question. You can do them case by case, or you can reverse this question. So we can do is, we can take everything together, which is every type of combination, minus the number of selection where we have no doctor. If that makes sense, it will be, this is the reverse of this. Same thing, same concept, but we cannot reverse the logic here to find this. That will be 1287 minus. Now, what is a selection with no doctor? So pretty easy. From 6, we don't choose anyone, so choose 0, right? And from the rest, we can choose, from the 7 people, we choose the remaining 5 people. That will be what? So 1287 minus 6, choose 0, times 7, choose 5. That will be 1266. That is one of the ways of doing this question. Now let's try the other case. If you guys prefer, that is also a way of doing this question. So here we have doctor, and here we have others. So at least one doctor means we can have one doctor, 2 doctors, 3, 4, and 5 doctors, because we only need 5 people in the group. Now for others, if you have 1, that has to be 4, 3, 2, 1, 0. So we have to add all the cases together. For example, for the first line, from the 6 doctors, we choose 1, and from the other, such as 7, so other will be dentist and nurse, that will be 7. 7, choose 4. Next option, here we have 6, choose 2, times 7, choose 3, or 6, choose 3, times 7, choose 2, or 6, choose 4, times 7, choose 1, and finally 6, choose 5, times 7, choose 0. So let's see what do you get for this part of the for this solution. So 6, choose 1, times 7, choose 4, plus 6, choose 2, times 7, choose 3, plus 6, choose 3, times 7, choose 2, plus 6, choose 4, times 7, choose 1, plus 6, choose 5, times 7, choose 0. That should give you the same answer, which is 1266. Okay, so that is 2 ways of solving the same question. You should get the same answer. Again, I apologize for the noise outside. I have no control over this, but anyways, it is what it is. Let's move on to question number 3. The committee contains all 3 nurses, so we have to choose all the 3 nurses. So pretty easy. First thing first, from the 3 nurses, we choose all 3. Then from the remaining people, here we have, as you can see, nurses apart, we have 6 plus 4, which is 10 people. Remaining people, we have to choose the remaining 2 people that we need. That'll be 3, choose 3, times 10, choose 2. That'll be 45 as your answer for question part 3 of question number 5. Now let's move on to question number 6. So a particle is initially at the point with a position vector of 30, 10. That is the initial position of the particle P, and moves with a constant speed of 10 meters per second in this direction. Okay, so part 1, we have to find the position vector of P after t seconds. So how do you find the position vector? It is equal to the initial position plus the velocity times the time taken. So this we know already. It is 30, 10, and t, it is time, we don't know, and we have to find v. So how do you find the velocity for this one? We have to use these 2 information. So v has to equal to this one. We have to find the unit vector in this direction. That will be over 4 square plus 3 square, that will be 25, and multiply by the speed. That will give you what? So 5, so that will be 5, 2, that should be minus 8 and 6. So minus 8 and 6 for this one. So the position vector of P, which is OP, right? We call this OP. That should be this. 30, 10 for the initial position, and then t times the velocity for P for the value of V right here. Now that is part A. Now for part B, as P starts moving, a particle Q starts to move in such that its position vector after t is given by this. Good news. Part 1, we have to write down the speed of this one. So pretty easy. To find the speed, we'll take this value right here. That will be what? That will be 25 plus 144. 5 square plus 12 square, that should be. That will be 169, and that should be 13 meters per second. That will be the speed of the particle Q. Now for part C, we have to find the exact distance between P and Q when time equal to 10. So pretty easy. So we first have to find the position of those two particles before finding the distance. So basically, we have to find the value of OP at time equal to 10 and the value of OQ at time equal to 10, and then find the displacement. So one by one, replace 10 in this one. Let's see what you get. That will be 30 minus 80, that will be minus 150. And we have 10 plus 60, that should be 70. So that will be the position of P at the time of time equal to 10. Now for this one, OQ, replace here, have minus 80 plus 50, that will be minus 30. Then we have 90 plus 120, that should be 210. As you can see, we have those 2 points. Now we can find the exact distance between them. So to find the distance, we have to find the vector PQ. That is one way of doing that. That will be OQ 30 to 10 minus OP, that should be this, and then simplify to see what you get. You will get minus 30 plus 50, that will be 20, and 210 minus 70, that should be 140. The next thing to find the exact distance, find the magnitude of this vector. So PQ basically means from P we're moving to Q. So that's the displacement from P to Q. Then you have to find the magnitude to find the distance between them. That will be 20 square plus 140 square. That will be so 20 square plus 140 square, that will be square root of 20, 1, 2, 3,000. Now this could be written as what? As 2 times 10,000. Yeah, right? So this could be 2 times 100 square, which is 100 root 2 units. You can check if you want to. So square root of 10,000, 100 root 2 units for the exact distance between P and Q at the time of t equal to 10. Okay, so let's move on to the next question. That is question number 7. It is given that f of x is equal to this function for x is more than this value. So write down the range of f. So pretty easy. So whenever you have to find the range of a function, you have to understand the graph of the function. For example, we have the y-axis and the x-axis. This is the x and y. For example, now x has to be more than this value. So this is what value? This is minus 1.5, right? Let's mark that point on the graph. So minus 1.5 will be somewhere over here, for example. So that will be my vertical asymptote, because it will never, as you can, it is always more than this, so it will never touches this line. So the idea is that if as the value of x will increase, the value of everything will also increase. So it will be something, your graph will be something like this. It will look something like this, if that makes sense, right? So as you can see, the range means the value of y. Y, we have to look in this direction. As you can see, it can take any value. So the range of f can be any values in the real numbers. You can write this for your answer, or you can write y, this as well, for your answer. Now for part B, we have to find f inverse and state its domain. So f inverse will be, first step is to let y equal to f of x 5 ln of 2x plus 3 divided by 5. You have y over 5, that will be ln of 2x plus 3. So simplify, that will be 2x plus 3 has to be exponential y over 5, 2x, that will be exponential y over 5 minus 3. And finally, x will be exponential y over 5 minus 3 divided by 2. So from this, we can conclude that f inverse, should be in terms of x, obviously. That will be exponential x over 5 minus 3 over the value of 2. Okay, that will be part 1 of the question. Now we have to state the domain. As you can see, whenever you see state, it should be pretty easy. That's the indication. So we have the understanding that the domain of f inverse have to equal to the range of f. Now because we know the range of f is found in part 1, which is real numbers, domain of f inverse will be x has to be in real numbers. So you always have to remember, whenever we have to describe domain, it is taken as x values, x, and the range will be the y values. So x will be these values in the horizontal direction, and range will be always in the vertical direction. That's the idea to describe your domain and range. Now for part C, on the axis below, sketch the graph of y equal to f of x and the graph equal to f inverse of x. Label each curve and state the intercepts on the coordinate axis. Now, so I guess we have to first understand that these two graphs, they are what? They are actually reflection in y equal to x. So that's something we have to know whenever we draw this kind of graph. So let me find a ruler here just to make that line first. For example, it will be, will be my line, right? Y equal to somewhat like this. It's not perfect, but hey, it is what it is. That will be y equal to x. Now this is my first step, and then here I have to show where it cuts my axis. So let's see. So for which graph let's start? Let's start for the first graph, which is f of x equal to 5 ln of 2x plus 3. Now when the value of x was 0, so when x was 0, the value of y was 5 ln of 3. That should be somewhere over here. 5 ln of 3, let's say it's somewhere over here. Let's see, so 5 was, so let's say it's somewhere over here. Why not? Right? And then when y equal to 0, that will be what? So that will be 0 here, that will be 5 ln of 3x plus 3, that will be exponential 0, that will be 3x plus 3. So 3x has to be 1 minus 3, that will be minus 2, x has to be minus 2 over 3. Okay, so minus 2 over 3, that will be 0.666, so somewhere over here, I would say. Let's say should be about this value. Now of course we have to always draw this line whenever we are dealing with log or exponential function. We have to draw the asymptote as well. This is minus 1.5. So let's draw this line. Should be somewhere over here, for example. So this is only an indication of a line your graph will never touch. That is, it just helps you to find the right direction for your graph. So that will be something like that. So let's say this will be in this direction. So not perfect, but you get the idea. So let's change that to here, 2 minus 6 here, because it's not perfect. So that will be, let's write down the other value. So that will be minus 2 over 3 for this point. And this will be, we have to write the exact value, 5 ln 3. So that's the first step. This is my graph of y equal to f of x. Now we understand that it will be just a reflection in this line, so we have to kind of sketch this. So here we go. Of course, you have to kind of make an effort to make it seem like a good reflection, not too bad, if that makes sense, right? Be something like this. So that will be y equal to f inverse of x. So this will be this point right here, which is 5 ln of 3, and this will be this point here, minus 2 over 3. As you can see, this will be your answer for question part C of question 7. Okay, so let's move on to question number 8. So here we have to show the left hand side becomes the right hand side. So how can we do this? So step by step, as always, let's see how can we simplify this. Okay. So here we have, right now we have 1. Let's look at the base. We have 1 cosec theta multiplied by sine theta minus sine square theta. Now, what is sec square theta? We know it is 1 over cos square theta. So the goal is to make the base in terms of cos, right? So let's see how can we do that. So let's try to simplify first. So here, what is this? So what is the term of cosec theta? We have to know it is simply 1 over sine theta. Now let's expand the brackets. So here we have 1 multiplied by this, you will get sine theta minus sine square theta. Then this multiplied by this will give you, so we have this will cancel out, plus 1, right? And then this will be minus sine theta. Now if you observe, this and this will be cancelled, and you will have 1 minus sine square theta remaining, which is equal to cos square theta. So now replace this one back in the main equation. That will be 1 over cos square theta is equal to sec square theta. This is shown as required. That is part 1 of the question. Now for part B, we have to solve the equation. Hence, as you can see, so basically we have to use that to solve this equation between these two. Now as you can see, this was found to be this. So we know that this is equal to cos square theta. So right now we have cos square theta is 3 over 4, which means cos theta is plus minus root 3 over 4. Okay, so let's try to solve one by one. So first one we have cos theta can be plus root 3 over 4. And since the value is positive, it will be in the first quadrant and in the fourth quadrant. This will be just the angle directly, and that will be 360 minus theta. Right, so let's find out what is the value. Okay, that will be this. Cos inverse of root 3, so 0.5, right? That will be 30 degrees. Right, that will be my first value right here. Cos inverse of root of 0.5 will be 30 degrees. That's the first step. Now, this will be 360 minus 30. That should be 330. Okay, now, as you can see, the values need to be between those values. So what can we do now is, we can try to minus 360 for each of the values to see what do we get. Now, by taking out the 360, we're not changing the values really. It's just that we are applying a different direction in viewing those values. For example, just give me 1 sec, I will explain that for you. That will be minus 330. That will be too much. And that will be minus 30. As you can see, from these answers, from this, and this, we have two solutions. That will be theta can be 30 degrees, can be minus 30 degrees. Now if you observe, for example, when I mention the angle of 30, so 30 will be somewhere right here. This is 30. But now, of course, the way we measured this will be from this direction we went to this direction. That makes sense. But now so we assume that this direction was a positive direction and we give it the value of plus 30. But now the same angle could also be measured in the opposite direction. So we can start here, measure here until here. That will be minus 330. So basically what it means is that 30 degrees is the same thing as minus 330 degrees. As you can see here, this is the same thing as this. So the reason why we do this in this question is because we don't want to miss any values. For example, here we solved this, we had two values, as you can see. This is good, but this will be outside the range. So usually we would have to cut this off. However, by doing this, you can see we have another value that we have used to find the second answer. So this is the first part for two values of theta. Now for this one by one, here we have cos theta should be minus this. That will be in this quadrant and in this quadrant. That will be the angle of 180 minus x, for example. This is my fake angle, and this will be 180 plus x for my fake angle. The reason why I'm using x right now is because I have negative here. So we don't find the value directly when we have negative. We try to use a fake angle. So x will be cos inverse of the positive value of this. And that should be 30 degrees, as we have seen before. So finally, theta will be, according to your quadrants, that will be 180 plus 30. That will be 210. And 180 minus 30, that should be 150. Now, as you can see, we will do the same thing here so we don't lose any values. So minus 360 to both to see what happened. That will be 210 minus 360. That will be minus 150. And here we have 150 minus 360. That should be minus 210. So here we have this value and this value, this and this to choose from. As you can see, this will be outside and this will be outside the range or domain. So theta has to be minus 150 and 150. So in the end, you will end up with four answers, which is this two and this two, for your value of theta for part 2 of the question. Now let's move on to part B of the question, number 8. So here we have to solve this equation for the angle of psi radians, giving you an answer in terms of pi. Now, as you can see, this one is pretty tough to work with. Let me first rewrite this as x. For example, you have sine x equal to cos x. Now, as always, when you have sine and cos in the same equation, I advise to divide by cos x. Let's see what happens. You will have tan x equal to 1. Right. Now I can solve for this. X will be tan inverse of 1. You will have pi by 4. Well, let's check. Of 1 is 45 degrees, which is pi by 4. Okay. And then we have to look at the quadrant. That will be in the first quadrant. And the third one. This is the angle directly, which is this. And this will be 180 plus x. So plus 180 plus 1 pi. That will give me a 5 pi over 4. Now, this is for the values of x. Obviously, we're not trying to find x here. We're trying to find 3 psi plus 2 pi over 3. That will be pi over 4 and then 5 pi over 4. Now, given that here we have 3, as you can see, 3 here, we try to add a few more values. So add 2 pi and add 2 pi. So we are sure that we're not missing any values to our answers. So let's do that. So pi over 4 plus 2 pi, that should give you what? 9 pi over 4, right? And this will be 8 plus this, that should be 13 pi over 4. So this is just to ensure that we don't miss any values. So let's solve now. 3 pi 5 will be 1 over 4 minus 2 over 3, that should be minus 5 over 12, this. And then we have 5 over 4 minus 2 over 3, that should be 7 over 12, this. And then we have 9 over 4 minus 2 over 3, that should be 1, 7, 12, this. And then finally 13 over 4 minus 2 over 3, that will be 2, 7, 12 of pi. Okay, now we have to find the value of just phi, divided by 3, minus 5 over 12 divided by 3, that will be minus 5 over 36. This will be 7 over 36 pi, and this will be what? So 1 over 7 over 12 divided by 3, that should be 19 over 36 pi. 2 over 7 over 12 divided by 3, that should be 31 over 36 pi. Now, phi lies between the value of, as you can see from the question, between 0 and 2 pi by 3. Now, what is 2 pi by 3? So 2 pi over 3 was 2.0943. So let's see which of those values lies within this domain so we can find the answer finally. So this was negative, it will be outside. We know that for sure. So now we have 7 pi over 36, that will be 0.61. This is good. Then we have 19 over 36 times pi, that will be 1.65, which is good. And finally 31 divided by 36 times pi, that should be 3.142, which is not good. So that will be outside of the value. So we have only two answers remaining. So the exact value will be 7 over 36 pi and then 19 over 36 pi for the value of phi for this question. That is part B of question number 8. Now for question number 9, given that we have the integration of this is equal to ln of 3, where a is a positive value, we have to find the exact value of a, giving you answer in the simplest third form. So one by one, how would you integrate this? So we can break it down first. That will be 1 over x by dx minus 1 over 2x plus 3 by dx. Now let's simplify to see what happens. That will become ln of x, right, between the domain of the limits of a and 1. Same thing here, that will be ln of the value inside, that will be 2x plus 3, divided by this value right here, which is 2, between the limits of a 1. So now to integrate this, you have to understand, for example, if you have 1 over 2x, that will give you first ln of the value of the denominator, that will be 2x, then divided by d by dx of the value inside, that will be 2. This is why, same thing, ln of this value right here, then divided by d by dx of the value here will be 2. Now this is only possible when this is linear. For example, if you were to have x squared at the bottom, we can't do this, we just have to simplify. That will be x power 2, then we apply this. It will be a different thing. Now simplify, let's see what happens. That will be ln of a minus ln of 1 minus, that will be ln of 2a plus 3 over 2 minus ln of 5 over 2. That will be 0, cancel out. That will be ln of a minus, so here we can take out the value of half if you want to. That will be ln of 2a plus 3 minus become divide by 5, this. Now we know this is equal to the value of ln of 3 given by the question. Now we have to solve for the value of a. So step by step, let's see what can we do. So we can try to combine these two. So first we can send this value over here. If you want to, obviously, it would be the value over here, right? So we know that this half, when you have half ln of a, we can send the power on top. That will be ln of root of a, for example, right? Now let's simplify this. Let's see what happens. So you have ln of a minus ln of root of 2a plus 3 over 5 equal to ln of 3. Now simplify this side. Let's see what happens. You will have ln a minus become divide 2a plus 3 over 5 is equal to ln of 3. These two will cancel out, and then we can try to cross multiply. You will have a, that will be 3 root of 2a plus 3 over 5. Now we can divide by 3. You have a over 3, that will be root of 2a plus 3 over 5. Then simplify, that will be a squared over 9, that will be 2a plus 3 over 5. Now we have to cross multiply to see what happens. You will have 5a squared, that will be 18a plus 27. So simplify, send everything to one side. Let's see how can we factorize this for the answer. Okay. So now we have a quadratic equation, as you can see, a squared and a, and then this. Let's use our formula to find the answer. So a will be the value of minus b, which is 18, plus minus root of 18 squared, which is b squared. That'll be 324 minus 4 times a times c. So 4 times a is 5 times c. That will be this. And divide by 2a will be 10. Well, obviously, we will only take the positive value here. That will be 18 plus root of 324 plus 540. That will be 864 over 10. Okay, so now we have to try to simplify this as simple as possible. So what is this? That will be not exact. So let's try to see what are the factors of 864. So let's try. 864 we can first divide by what? Divide by 4. So divide by 4. You have 216. Divide by 4 again. You have 54. Divide by 4 again. No, we can't divide by 4. Divide by 2. You have 27, I think. And divide by 3. 9. Divide by 3. You have 3. So basically we have realized that 864 is equal to 4 power 2 times 3 power 2 times 2 times 3. So basically square root of that will become what? It will become 4 times 3. We can take that out because we can remove the square, and that will be 6, which will be 12 root 6. So a has to be 18 plus 12 root 6 divided by 10. That will be, you can write 1.8 plus 1.2 root 6 if you want to, for your value of a in the simplest form. Now for part B of the question, let's see what do we have. So here we have to find the exact value of this. So step by step, as always. So that will give you what? So first thing first, integration of sine will give you minus cos. Of the value inside, that will be 2x plus this divided by d by dx of the inside value, that will give you 2. Then minus x, then plus sine of 2x divided by 2. And the limits, as you can see, it is between pi by 3 and 0. So pi by 3 is 180. Divided by 3, that should be 60 degrees. So we have to find the exact value of that. So simplify. Minus cos of, that will be 2 times 60 will be 120, plus 60, that should be 180. Divide by 2, minus pi by 3, plus sine of 120, right, this is 120, over 2, then minus, that will be what? Cos of, that will be minus cos of 60 over 2 minus 0 plus 0. Because sine of 0 is 0 and x 0 here 0, right? Makes sense. Now let's simplify. What is cos of 180? That will be minus 1. So minus 1 times minus will be 1. So 1 over 2 minus pi over 3. What is sine of 120? That will be this, which is root 3 over 2. So let me write this down. So root 3 divided by 2. So root 3 divided by 2 should be this value, right? So we know this is plus root 3 over 2 divided by 2 will be root 3 over 4. Then minus, the value here will be, cos 60 will be half, so minus half will be, so we have minus half over 2, so minus half divided by 2 will be minus 1 over 4. Then plus minus 0 will be 0. Simplify to see what we get finally. That will be root 3 over 4. Then we have half plus this, that will be plus 3/4. And then we have to minus pi over 3. That will be your answer for question part B of question number 9 as the exact value. Okay, so let's move on to question number 10. So here we have a progression. It is called the arithmetic progression. So whenever you see this, just go back to your sheet of formula. You will see that you can write this down on your page first thing first. So here we have the n term, which is given by this formula, which is a plus n minus 1 times d. The sum of the first n term will be half times n times 2a plus n minus 1 times d. Okay, that is the first thing we can do. Now, here we can see it has a second term, so u of 2 is given by 8 and u of 4 is given by 18. That's the two things we know right now. Now, find the least number of terms, so find the least value of n, the term, for which the sum of this progression, for which s of n has to be more than this value. Okay, so first use these two to find the value of a and the value of d. Then we have to find the value of n for which s of n will be more than this. So one by one, let's form two equations. So first thing first, this one. So that will be u of 2 is 8, that will be 8. A plus n minus 1 is d, that will be this one. So this is my equation number 1. Now u of 4 is 18, that will be 18. That will be a plus, so that will be n was 4, 4 minus 1 is 3, so that will be 3d. That will be number 2. From this I can see that a has to be 8 minus d. Replace this back in my second equation. You will have 18 equal to 8 minus d plus 3d. That will be, send this over here, that will be 10 equal to 2d. So finally, d will be 5. Now, a will be 8 minus 5, that will be 3. Now we know the value of a is 3, and then the value of d is 5. We can move on to the next part, which is this one. We are trying to find the value of n for which s of n has to be more than 1560. S of n is what? It is half n. 2 times a will be 6, right? Plus n minus 1 times d, which will be 5. Has to be more than 1560. So let's simplify. We can send this value over here, right? By cross multiply, you will have what? N 6 plus, that will be 5n minus 5, and that should be 1560 times 2, that will be 3120. Simplify, that will become 6n, simplify first. 6 minus 1 is 1, 1 times n will be n, plus 5n square is 3120. So simplify, you have 5n square plus n minus 3120 equal to 0. As you can see here, we have a quadratic equation, so we can solve this step by step. Of course, I missed something here. It is this one, right? It has to be more than this. Now we send this over here. We will have this for now. So right now we will have something like this. Right. So as always, this kind of equation will be solved by using the graph method as well. So let's see what can we do right now. So the idea here is that we have to find the critical values. That will be 5n squared plus 8 minus 3120 equal to 0. So this is n, not 8. Okay, so let's solve this by using the formula if you want to, because it seems kind of not easy to solve this one directly. Let me see what can we know. Not good enough. Let's see what can we do. So n has to be what? Minus b, that should be minus 1 plus minus b squared, so 1 squared minus 4 times a times c. That will be this, 62401 divided by the value of 10. So minus 1 plus root of 62401 divided by 10, that will be, n can be 2488 this, or n can be, the other value will be minus 1 minus root of 62401 divided by 10, minus 25.08. Now this is not the value we're trying to find. Basically, we have to first obviously draw the line of 0. The graph shape will be in this direction, and here we have the 2 points. This is the first point, minus 25.8, and this is the value of 24.88. More than this will be this and this. So basically here we can conclude that the value of n has to be more than 24.88, or n has to be less than minus 25.8. But obviously n cannot be negative. This will go away. Now we take n has to be more than 24.88, which means the next term is 25. So n will have to take the value of 25, for which the sum will be more than this. That will be part A of the question. Now let's move on to part B of the question. So here we have a geometric progression. So whenever you see that, go back to your list, you will see these ones. So let's write these one on the page so we can use that for the question easily. So the n term is given by a r n minus 1, and then we have the sum to infinity has to be a over 1 minus r when r has to be less than 1. Okay, so the progression has a sum to infinity of this, which means sum to infinity is given by 72. Now, the sum of the first 3 terms of this progression is this. Okay, so how would you find the sum of the first 3 terms? Pretty easy. So, first term is given by a, second term will be given by ar, and third term will be given by ar squared. So basically, a plus ar plus ar squared have to give you 333 over 8. Right, that's my second equation. Now from this one I can derive what? A over 1 minus r has to be 72. Okay, so a has to be 72 times 1 minus r. That should be 72 minus 72r. That is the first step, I guess. Now, using those two things, find the value of the common ratio. So find the value of r using those two equations. So one thing I can do here is I can factorize the value of a. You will have 1 plus r squared, 333 over 8. Now I can try to cross multiply. Right, you will have 8a times 1 plus r squared is equal to 333. So let's see, let's replace and see what happens. So replace a here, you will have 8 times a, which is 72, and that'll be 1 minus r times 1 plus r squared, 333. So let's simplify. So we can divide by 333 divided by 9. That will be this. So divide by 9 everywhere, you will have 8 times 8, 1 minus r times 1 plus r squared, and that will be 37. Okay, so now we have to try to solve this equation. Let's see, what can we do? Can we factorize? Can we use something else? Or can we use another formula as well? So I think we could use something else. I forgot the formula here. I apologize for that. If you see here, we have what? The sum of the first n term is given by this. So I forgot to use this one. This is my fault. Let me write this down again. Sum of the first n term is given by this formula, which is a 1 minus r power n over 1 minus r. So the sum of the first three terms is given by 3 over 8. Because if you were to do this, it will be pretty hard to solve. It will be a cubic equation. We will have to find solutions one by one and then find the answer. But given that there's only so much space, I don't think that's the right solution to use. We have to use this one. That will be a times 1 minus r power 3 over 1 minus r. That should be 3 over 8. That should be my equation number 2. So let me write this down on a new piece of paper to solve this. So right now, what do I have? Right now I have the sum to infinity, which is 7/2, is given by a over 1 minus r. That is my equation number 1. The next one I have the sum of the first three terms is given by 3 over 8 is given by a times 1 minus r cube over 1 minus r. This is my equation number 2. Now something we can do here is we can try. Let's try to do something. We can take number 1. As you can see, when you have two equations with two values, we can solve simultaneously, obviously. But we have to try other ways as well to see if that's possible or not. For example, I can take equation number 2, let's say, or number 1, divide by number 2. Let's try. Why not? You will have a over 1 minus r divided by a 1 minus r cube 1 minus r. Okay, that will be something like this. Let's see, what do we get. Now you have to change this to multiply. You will have a over 1 minus r multiply by 1 minus r over a 1 minus r cube. Now if you observe, these two will cancel out, right? So you will have what? You will have 1 over 1 minus r cube. This is for this side. And for this side, let's see, what do we get. So 1 is 72 divided by 333 over 8. You'll have this value, which is 127 over 37. So let's see, what is that. So 1 times 37 plus 27. So I'm just expanding this one. This is the same as 64 over 37. Now we can just send this value, cross multiply. You will have 37 over 64 has to be 1 minus r cube. So r cube has to be 1 minus 37 over 64. That will be 27 over 64. So finally, r has to be cubic root of this. That will be 27 over 64. We have to know that this is 3, and this will be, let's see, what do we get here. Cubic root of 27 will be 3. Cubic root of 64, that should be 4. So r has to be the value of 3 over 4 as your answer. So this is your answer for part 1, which is r is 3 over 4 right here. Now for part 2, we have to find the value of the first term. So find the value of a by using this. So going back to this equation, we know that a over 1 minus r, which is this, have to give you 72. So a over what? 1 over 4 has to be 72. So finally, a has to be 72 times 1 over 4. That should be 18 as your answer. Okay, so that will be your first term of this progression. So I think that was the last question of this paper. I hope that was somewhat helpful. As always, thank you for watching. I will see you soon.